Hello, Riles. Let's take a look at another example from 5.2, compound angle formulas. We're going to find the exact value for the sine of 17 pi by 12. It says a calculator is not required. We know we're looking for an exact value because it doesn't say otherwise. It also says a calculator is not required, so I'd be surprised if we'd be looking for an approximation. So we're going to try this example in radian mode and in degree mode. In degree mode, students usually find it easy enough to work with a calculator to try to find a sum of two angles. I would like to see your work for what it is that you're doing to find a sum of two angles that add to 17 pi by 12. This is our approach here. I don't recognize 17 pi by 12. I don't recognize its related acute angle. I'll take that approach in a sec. So what I'm going to try to do is find a way to use my sum formula. I know, or I will be given, that the sine of a plus b is the sine of a times the cosine of b plus the cosine of a times the sine of b. So this is my goal. This is my plan right now. I'm going to try to figure out how 17 pi by 12 can be written as a sum of two angles. I'm going to go off to the side here and experiment with 17 pi by 12, just so that I don't have to write out the sine of every single time. So here's my advice for finding two angles that add to 17 pi by 12, if this is the approach you're going to take. Find two numbers that add to 17. You can try 1 pi by 12 plus 16 pi by 12, but we usually shouldn't ever have to do two decompositions. You might look at pi by 12 and say, oh, I know how to find the exact value for pi by 12, but I don't want to have to split that up. So you know what? I don't love this, this decomposition, so I'm going to stop that. Let's try 2 pi by 12. Actually, I should write vertically here. Let's try 2 pi by 12 plus, well, that'd be 15 pi by 12, right? And this looks like a better option because I recognize that 2 pi by 12 is actually pi by 6, and 15 pi by 12 can be reduced down to, let's see if I divide by 3/3, 5 pi by 4. I'm going to advertise this option in a sec. I just want to show you that there's usually more than one way to get this done. If we tried 3 pi by 12 plus, it'd be 14 pi by 12. That would add to 17 pi by 12, and this would reduce to pi by 4 plus 7 pi by 6. And sorry, I like both of these options because I recognize the angle pi by 6 and I recognize the angle 5 pi by 4. I could draw sketches in standard position to find exact values for all four of these angles. Okay? And I'll try to convince you that you'll get the same answer no matter how you decompose it. If I kept trying other options, I would have tried 4 pi by 12 plus 13 pi by 12. I don't like 13 pi by 12. I don't recognize it, so I'm going to skip that option. How about 5 pi by 12 plus 12 pi by 12? This one seems like we should dismiss it because we don't recognize 5 pi by 12, but this is actually one of the other approaches that I'll take here, is saying basically that that's my related acute angle right there, isn't it? So I'll cross this one out here, but I'll come back to this approach in a bit. 6 pi by 12 is nice and round, but 11 pi by 12, yeah, no thanks. What about 7 pi by 12? I don't like 7 pi by 12. No. 8 pi by 12 plus 8 plus 8 is 16, so to get to 17. Well, I should have just noticed the pattern here that I'm decreasing by 1 there. Yeah, wait a minute. 8 pi by 12 plus 9 pi by 12 could reduce to, let's divide by 4/4 there, 2 pi by 3 plus, and divide by 3/3 here, 3 pi by 4. I notice I'm kind of out of my options here because my next combination would be 9 pi by 12 plus 8 pi by 12. So yeah, we have three options here that should work. I kind of like this one the best, I suppose, because it has, well, I don't know. I'm not sure that I have. All of these have one acute angle in it and one non-acute angle. And every single one of these would take a little bit of work because I would have to visualize. When I write out the sine of 17 pi by 12 as the sine of 2 pi by 12 plus 15 pi by 12, which is going to be the sine of pi by 6 plus 5 pi by 4, and then I break it down into, okay, this is going to be the sine of pi by 6 times the cosine of 5 pi by 4 plus the cosine of pi by 6 times the sine of 5 pi by 4. The slight disadvantage to any one of these approaches here is that I might have to put in a little bit of work to get the cosine of 5 pi by 4 and the sine of 5 pi by 4. The good news is, though, that a single sketch of 5 pi by 4 right here will give me both the sine and the cosine ratio. We're going through negative a comma a with a radius of root 2a. So I should feel comfortable substituting in. Let me get my pi by 6 on there as well. I guess I shouldn't use the same a value here, right? Let's call it, I don't know, b, 2b, root 3b. I get that the sine of pi by 6 is 1/2, that the cosine of 5 pi by 4 is negative 1 over root 2, that the cosine of pi by 6 is root 3 over 2, and that the sine of 5 pi by 4 is negative 1 over root 2. And then I can tidy this up and simplify it to negative 1 over 2 root 2 minus root 3 over 2 root 2. The question might have asked us, or might ask us in the future, to rationalize our denominator. This one did not. If they had, we would multiply by 1 to get negative root 2 minus root 6 all over 2 times 2, or negative root 2 minus root 6 all over 4. Let's just pick one other one here and convince ourselves that it gives us the exact same expression. You try the third. I'm going to do, how about this one, because it's got a pi by 3 in it instead of another one with by 6s. So if I had done the sine of 17 pi by 12 is the sine of 8 pi by 12 plus 9 pi by 12. Again, please show this to your reader to convince them that you're working by hand. I'm usually suspicious if people claim to be able to see that 2/3 plus 4/3 is 17/12 by I. This is going to be the sine of, what did we say there? 2 pi by 3 plus 3 pi by 4. Which is going to be the sine of 2 pi by 3 times the cosine of 3 pi by 4 plus the cosine of 2 pi by 3 times the sine of 3 pi by 4. So my sketch in standard position this time is going to involve an angle of 2 pi by 3 right there. I'm going to say that's going through negative a with a radius of 2a, so positive root 3a. And it'd be a little bit crowded in there, so let me just get a different sketch. 3 pi by 4. Let's call this negative b comma b with a radius of root 2b. It's going to be, let's see, sine of 2 pi by 3 is going to be root 3 over 2. Cosine of 3 pi by 4 is going to be negative 1 over root 2. Cosine of 2 pi by 3 is going to be, plus cosine of negative 2 pi by 3 is going to be negative 1 over 2. And sine of 3 pi by 4 is going to be 1 over root 2. Now, these numbers sound a little different than the last time, but they also sound a lot the same as the last time. The order is just a little bit different. If we tidy it up, we get negative root 3 over 2 root 2 minus 1 over 2 root 2, which is negative root 3 minus 1 over 2 root 2, which is the exact same thing as this expression right here. It's in just a different order, and we could have rationalized as well. Okay. The related acute angle approach, I think, was as advertised in the lesson, kind of takes this pathway, but doesn't really depend on the angle sum formula. Instead, perhaps it would have been beneficial to start by sketching the original angle. Okay, there's nothing wrong with these approaches, but it might take me a little bit of time to do the trial and error and pick one. I probably, as soon as I found a combination that worked, I probably should have just gone with that combination if I'm doing this on a test or a quiz. Right. Let's see. The original angle was 17 pi by 12, right? So this is pi. That's 12 pi by 12. I guess this being 3 pi by 2 would be 18 pi by 12. So I'm going to sketch my angle right about there. There's 7 pi by 12. And if I just use my 5.0 understanding here, if I call this, I've already used the letters A and B a couple of times here. Let's call this D, comma, actually I'll call it negative D, comma, negative E, with a radius of F, I guess. Then this would have a radius of F, and it would be going through D, comma, E. So I could probably speed this process up by saying that the sine of 17 pi by 12 is going to be the opposite of the sine of this angle right here is going to be 17 pi by 12's related acute angle, which is going to be 17 pi by 12 minus pi, or 17 pi by 12 minus 12 pi by 12. Maybe it's not faster, but some students like to always come up with an expression in terms of a related acute angle. And then this opens up all sorts of other possibilities, because it turns out that there's plenty of ways of finding angle sums or differences that are 5 pi by 12. I'll just pick one here and write 5 pi by 12 as, to speed up the process above, I'm only going to look for decompositions of 5 that are divisible by 12. So I'm not going to try 1 and 4 because 1 isn't divisible by 12. I'll go with 2 and 3. I like sums best. So this is going to be the opposite of the sine of pi by 6 plus pi by 4. So it's not much of an advantage, really. In the last two examples, all I needed to do was draw sketches of angles that were outside of the first quadrant. The only advantage here would be if a student had memorized trig ratios on pi by 6 and pi by 4, which I've never suggested that you do. If you're going to be drawing a sketch in standard position for these anyways, then you might as well just stick with any principal angle. The other thing to be careful of here is the sine sum formula is a polynomial. It's a binomial, and this binomial needs to be multiplied by -1, and this is often done improperly. I'm going to put my sine sum formula on the inside. It is going to be the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. And notice I want to make sure that I subtract both of those. Okay. So once again, it's going to look a little different than the previous expressions, but if we look at it carefully, it's going to look very similar. Sine of pi by 6 is 1/2. Cosine of pi by 4 is 1 over root 2. Cosine of pi by 6 is root 3 over 2. Sine of pi by 4 is 1 over root 2. So we get the opposite of, this already has a common denominator, 1 plus root 3 over 2 root 2, which without the square brackets works fine as a final answer. If I distributed the negative through the numerator, I would get -1 minus root 3 all over 2 root 2. And I could rationalize it to negative root 2 minus root 6 all over 2 times root 2, which is 2 times 2, which is 4. So I get the exact same answer as my first time, and just a rearranged answer as the second. Okay. I don't think that advanced function students should have to convert these angles into degrees, just so that they find addition easier. Addition of fractions will be easier when you practice adding fractions. So practice adding fractions, and it'll be easier. Try it out.